In this video, I wanted to cover the definitions of inputs and outputs in process control. And as basic as this may sound at the surface, it is a lot more complicated because you need to fully understand the control objective of the situation before you begin to label anything as an input or output. And as easy as it is to look at a CSTR and begin to think that you know that your outlet stream has to be an output and your inlet stream is some kind of input, that just isn't the case, because sometimes we'll have valves on our output streams. Quite often you'll have valves on your output streams, and to a process control engineer, this output stream is an input. And so you cannot think this way. It just doesn't work. And so to really begin to better define what these things are before you jump into defining situations yourself, I wanted to kind of give a somewhat retrospective definition of how I think of inputs and outputs in process control. And so I try to think linearly here, in that number one is fully understand the problem statement, fully understand the control objective. What are you trying to do here? What are you trying to control? What is the set point value in this process? Sometimes your set point value will be some kind of height inside a CSTR. That is what we care about. And so if H is a set point, then we would consider both our inlets and our outlet streams, if we had valves on them, to be inputs in our process. But that's only because we fully understand the control objective, which is to maintain the height inside of a surge tank at some level, for instance. So once you understand what your set point is, the next thing is, so you kind of start by defining what are your outputs in your system, or your output. And then once you know what your output is, then you can move on and say, okay, in this black box in my system, what can I change that will help me achieve this set point? And these are what I would call your inputs. So first, understand the problem, then understand what is the output, and then understand what are your inputs. What are the things that your process controller, I call it PC, can actually change in this process in order to help maintain some set point value inside of your reactor. And another thing that is commonly defined as inputs are disturbances, because let's say I have an open system here and it begins to rain, and so I've got a bunch of rain coming in, and now I've got this new stream, and that rainfall each year, that could be a disturbance variable in our system that we really don't have any control over, but it is definitely influencing the set point value of our process, and therefore will be some kind of disturbance input in our system. And so this is something that I really wish I could beat into myself earlier on when I was first learning process control. To work through an example problem, just to kind of hit home how I would approach a new situation, would be something to consider the following. So let's say I've got some kind of CSTR, I've got some feed streams coming into my process, I have an effluent stream leaving my process, and what things do we really care about if we're thinking as a chemical engineer right now? So our control objective, which is point 1 here, is to achieve some kind of purity of a product, and also some kind of flow rate for this product. Flow rate of product. So our control objectives here, we've got essentially two set point values. We've got, X sub A, which would be the mole ratio of A, or some kind of product in an effluent stream. And then we would also have a flow rate of our product, F sub A, which would be also coming out of our effluent stream. And so in this process, we're going to have some kind of set point value for these numbers. So purity of a product, so you'll be told by your supervisor this needs to be at least 80% pure, and we need at least 20 moles of this per second. So these are your control objectives for this particular process. And so in that case, now what we would know would be the outputs of this process. And when I get excited, sometimes I have a hard time writing correctly. The outputs of this process in this case would be X sub A and F sub A. And I would say, sorry, we would have some kind of inlet flow rate F1, another inlet flow rate F2. We would have valves on these two streams. We would have some kind of mixer. You know, if we were to consider, you know, and I'm going to be putting work into this mixer, what we could consider as inputs in this process, things that can control the outputs in this process would be the flow rate F sub 1, the flow rate F sub 2, as well as however much work we're putting into the stirrer. And this is how I would define inputs and outputs in this process. And just to recap, number one, and this is something that I struggled with, so that's the reason why I care so much about this in this video, is make sure you fully understand a control objective. And I'm sorry I've said this 3 or 4 times now, but my problem, especially because I'm an engineer and I don't really fully read as much as I should every time, make sure you know what are you trying to do here before you just jump into a problem and assume things. Like, it's very easy to assume we just care about outlet flow rates, but you know, sometimes an output here would be like F total, so F tot, and in that case, even though it's in your effluent stream, it's really an input because it's another piece of information that your process controller can use or potentially change in order to influence, you know, F sub A and X sub A. And so this hopefully helps clarify some things for people, hopefully earlier on in their academic careers than it did for me. Let me know if you guys have any questions, and thank you for watching.